So in this video, we're going to be looking at two different theorems here. The first being the perpendicular bisector theorem. In this theorem, I have some point P that I'm going to say is on the perpendicular bisector of segment AB. So to be a perpendicular bisector of a segment, first of all, it has to be perpendicular. But then it also has to bisect segment AB. Well, if we were then measure from P to A and P to B, those two lengths should end up being the same. This is easy for us to actually verify because we can actually, if you notice, we have two right triangles that our perpendicular bisector has broken this into. They share the segments that's our perpendicular bisector, and then I actually can see I have side, angle, side for the two triangles. So these two triangles are congruent, and by CP/CTC, PA, the length of PA is the same as the length of PB. So in other words, point P is equidistant from the endpoints of the segment. And that means then also vice versa, if I have a point that's equidistant from the two endpoints, it must be on the perpendicular bisector. The other theorem I wanted to look at is the angle bisector theorem. And this says that if I have a point P that's on my angle bisector, so I want to bisect angle ABC. Well, when I measure the distance from P to either side of the angle, remember we measure from point to a segment in terms of drawing a segment that's perpendicular to that other segment. Well, if you notice here, I do have a shared side, and I have angle, angle, side. These two triangles are congruent. So by CP/CTC, the length of PA is congruent to is the same as the length to PC. So as long as P is on my angle bisector, it's equidistant from the two sides of the angles. But it also means if P is equidistant from the two sides of the angles, then it must be on the angle bisector. And this is important for us because now, if you think about it, when we deal with triangles, the name literally means three angles. And what we're going to be looking at are what are called points of concurrency. So first I need to talk about what is a concurrent line. What are concurrent lines? The concurrent lines are three or more lines that intersect at a common point. So the blue I have here is an example of I have three lines, 1, 2, 3, that are all intersecting at one point here. So those are concurrent lines. Whereas in the red picture here, I have three lines, but not all three of them intersect at one point. Two intersect here, two intersect here, two intersect here. But those are not points of concurrency, because to be a point of concurrency, you must have at minimum three lines intersecting there, not just two. In our next video, we'll actually start looking at points of concurrency in our triangles.